Welcome back. In this video, we are going to continue working with portfolios. In the previous video, we had a series of returns for 5 different assets, and we had the risk-free rate, and we calculated average returns, standard deviation, Sharpe ratio, and we identified a few of the items in that table. We also created a covariance matrix. So we can now use these covariances between the assets to start looking and building efficient portfolios down here. And that's what we're going to start this video on. The idea is that we want to create a portfolio with a minimum variance. That'll be the portfolio with the lowest risk possible given these 5 assets. We also eventually will calculate the one that will give us the maximum return. So we're going to have the lowest risk or the highest return. And then we're going to build a series of portfolios in between those 2 points, shifting them 10% at a time to then have a series of portfolios to represent what we're going to call the efficient frontier. So let's start with the minimum variance portfolio. We are going to use Excel Solver for this. And Solver is going to tell us the weights that we're going to have here for each asset, how much money, what percentage of the money we're going to put in each asset when we invest it. But in order for Solver to know what to do and what results give us here, we got to set up some formulas for it to follow. So let's first start with the fact that these assets, the percentage, must add up to 100%. So here, we're just going to do auto sum, and we're going to put it there. It's going to give us a 0% right now because we have nothing there. But when we tell Solver to look in here, we're going to tell that whatever combination of weights, it must be 100% here. Cannot exceed 100% because that'll be 100% of your money. Now, with standard deviation, we could use the standard deviation function for a sample that Excel has for us. However, then it could get complicated on how to use a covariance with the returns and then be able to use the formula across the table. So we're going to use an array and matrix multiplication. So if we're going to do that, what we'll do over here is for standard deviation first, we're going to start with a square root, which is a typical calculation that we do when we do standard deviation. Now we are going to do a matrix multiplication of another matrix multiplication. So we're going to have 2 of them. So array 1 will be another matrix multiplication. Now this matrix multiplication will be calculated by transposing the values that will eventually be here. 1 second, please. I need to open the parenthesis to transposing the values that eventually will be here that will be populated by Solver. Once we have those identified, we'll look at array 2, which is going to be now the covariance matrix values. Now, what I'm going to do is I'm going to lock those in place with the dollar signs so we can later use the same covariance matrix for all the other portfolios that we will build. Once we have this piece of the matrix completed, we want to go ahead and give the second array of the original matrix multiplication, which will be, again, the weights that we will have here. Once we have those in place, we can close them out. Now, remember, this is going to be an array function. So we are going to hit Control-Shift, hold it, and then hit Enter. It's not going to give me a value right now. It's going to tell me that they can't calculate, but that's because, well, we don't have anything in there yet. So let's set up the expected returns of whatever portfolio we get once we know the weights there. So the expected return is going to look a little different, but we're still going to do an array. So in this case, we're going to do a sum of the transposed values that we will have here And those are going to be multiplied by the average returns that we have here. Now, once again, I'm going to lock these in place so I can later use them in the other portfolios. That one actually stops there, but we still have to hit Control-Shift-Enter. So understands that it has to do an array and a matrix type approach. Now, once we have those pieces of information, the Sharpe ratio will be the standard calculation of whatever the expected return is of the portfolio minus the risk-free rate. I'm going to lock that one in place because we can use it later. And then divided by what we get by the standard deviation. Once again, we don't have an answer yet because, well, we're waiting to see what solver is going to give us here as the best weights that will then give us the lowest standard deviation. So what we do then is go to solver. Let me go ahead and clear them so we can start. All right, so what is our target? Our target is to minimize the variance. In other words, the lowest standard deviation available. That's what we're looking for. So we're going to go ahead and target the objective. It's going to be this value here. We want that to be minimized. So we have to select minimize. I want the lowest one there possible. And I want it by changing numbers in here. All right. Now, we do know that this sum of those numbers must add up to 100. So we're going to add a constraint. We're going to add a constraint where this cell must equal 1, as in 100%. I'm going to hit OK. And so everything, we verify our values, everything looks good. Hit solve. It tells us that it found a solution. We hit OK. And what we have now is that with these weights, we can achieve these expected returns in that standard deviation. So in this example that we did, notice that all these numbers are 0 or positive. That's because at this point, we didn't allow for short selling in this situation. But we don't have that constraint. We are allowed to short sell in this scenario, this example. Now, sometimes it's not allowed. So if you're like in a pension fund doing a portfolio, they may have that rule where you cannot short sell because of the higher risk that it implies. So this would have been the approach. Now let's show what happens if I'm allowed to short sell. So we go back to solver. Now we already have the same inputs in place and the same constraints. However, what I'm going to do is I'm going to take this check mark off you see here. This check mark was forcing them to be 0 or positive. In other words, non-negative. So you can have that check mark saying no short sells. So in this example, I take it off. Now I'm allowed to short sell. So I can run the solver again. And now it gives me a new set of solutions where I'm allowed to short sell in some of the assets. So when you see the negative percentage, that is telling you you want to short sell those by that amount and those weights. And then you want to go long positions on these weights. The point is that it still adds to 100%. Now we see that the standard deviation is a lower at a 1.9%. So we have more options that we can work with, giving us a more efficient portfolio. The expected return here is 0.39%. Those are monthly returns. And the Sharpe ratio is 0.1169. Now let's go ahead and go all the way to the other extreme. We want to calculate the maximum return. So what we can do is these formulas, since we already had the dollar signs in place and where they belong, we're going to set them there. Now, of course, we don't have values in place or results because we're waiting for this. So in this case, what we're going to do is we want to maximize the return. And how do we do that? Now, we want to maximize the return while achieving the lowest standard deviation possible, because you still want to be efficient. Now, we're not going to do the lowest standard deviation overall, but the lowest standard deviation with the maximum return possible. Now, we do know that from all these assets, the highest return we can get is 1.78. So one way to look at it is, well, if I want the highest return, I'll just put all my money here on this asset. And that way I get the highest return possible. But the question is, can I still get that return with less standard, a lower standard deviation, less risk? And that's what we're going to try to find here. So what we're going to do is we're going to go back to Solver. We're going to make some adjustments. Okay, so we still want to minimize the standard deviation. So our set objective is going to be here now. We still want to minimize it. The cells we want to change are now going to be these. The constraint, we're just going to go ahead and change it, let it know that I want this constraint now to be equal to 1, as in 100. We still want to be able to short sell, but we're going to add another constraint. In this case, we want the return to be equal to the highest return possible, with a standard deviation the lowest possible. And we're hoping to get a standard deviation lower than 6.04%. So we're going to add a constraint. We're going to say that the expected return must equal the maximum return here. Now we have those. We took off the check mark so we can short sell, and this is solved. And it says that it found a solution for us where if we use these weights and we short sell this stock, we can achieve the 1.78 monthly return. That is the highest we can achieve with these assets. However, the standard deviation is lower. So it's better for us to build this portfolio than to just invest in that one asset. And here the Sharpe ratio naturally came higher as well, which we want a higher Sharpe ratio, 0.2764, which is higher than that one or the maximum we have. So we improved by balancing the portfolio in this fashion. So now what we're going to do is we're going to go ahead and calculate some in-between portfolios between these two ranges, maximum return versus lowest risk. For this example, we're going to move them at a 10% increments. We're going to change the weights with a 10% increments. Now, it doesn't have to be 10%. This is just so we can build the example. It could be 0.5%, 1% increment. It could be infinite amounts, but this is just for the illustration. So the way we can do it, since we already have these values here and these values here, we can use those values to start shifting. So what we're going to do is, instead of using 22%, we're going to decrease this percentage by 10%, but then increase this by the opposite amount. And this is what I mean. So this is how we will start the calculation. So we do know that we're going to use 90% of this amount. So I start equal 90% times this weight. So we're going to bring it down. But I'm going to then use the opposite of that amount, which is 1 minus that 90%. Now it's 10% times the maximum return we had here. So what we're doing is we are shifting 10% out of here and into here. And that's the new weight we're going to use. And that's how we're going to move along the other ones. So if I was to drag this down, I would want to lock in some values in place. For example, let's put a $sign here, which is my 90%. I don't want it to move, but let's just put $1 sign there on that value. So I don't want it to move down because I'm going to drag them down. And the K12, I'm not going to touch it because I want it to continue moving down this way. However, for when I go to the right, I do want to have a $sign there. And I'm going to do the same approach here and the same approach here. Now, the reason I do that, let's go ahead and make it a little better. And so now I can just go ahead and drag the formula. And these are the weights that I should expect to see if I shift those percentages. So what happens? I can go ahead, this is a sum of those. I can go ahead and might as well take it all the way. These, since I already locked in the right ones in place, I can just do the same down here. Now, as I fill these up, these are your portfolios, your efficient portfolios. As you can see, the standard deviation, as I went away from the optimal situation for the lowest risk, as I moved away 10% at a time, the standard deviation starts going up and up. So you're taking more risk as you move over here. However, you are getting then more returns as you take more risk. And then what we do is we look at the risk-return relationship. The Sharpe ratio is going up, which is a good thing. The higher the Sharpe ratio, the more efficient your portfolio. However, there's a point where it keeps on going up, then it stays steady. And as you can see, the Sharpe ratio then starts declining again. Now, you're still efficient. That's just the best you can do at these higher returns. Now, let's take a look at this graphically. Let's say I want to do the standard deviation against the expected return. I can go insert, go to the tables, go to all charts, and we're going to go to the XY scatter. And let's select this one here. And what you see here is the efficient frontier. All the portfolios on this line, the dots represents the one that we created, but you can have a portfolio in any place on this line, and it will be an efficient portfolio. And that is our portfolio piece using Solver and the efficient frontier.